Yeah, we are looking at the linear differential equation. Okay, and then we must note that the first order differential equation can be written in this form. Your a1 times x y dx. You can see. Okay, your a1 is just a constant value. Okay, a subscript 0 is a constant value. Okay, but in a more better way, we can write it in this form. In a more better way, it will be the y dx plus p of x y equal to what? Equal to f of x. So this is more better way to write our linear differential equation, and this is what this is the standard form. This is a standard form. Okay, and what happened here is that when you have it in this first form, what you're going to do is to remove the attachment to your dy dx. That means you have to divide through by what you have here. Okay, is that clear now? So by so yeah, you can see dy dx. There is no more attachment to that dy dx. Okay, then you have your constant y, which is what p of x with y, and equal to what f of x. Okay, and what we are telling you is that the attachment to y must be a function of x, must have a variable x. Okay, and that's that. But in a nutshell, this is the standard form. Okay, we're going to look shortly on how to solve a linear differential equation. Okay, look here. Determine if the following differential equation are linear or not. So we want to see if they are linear or not. Look at the first one. The first one, we are expecting x squared. Well, you see x squared y. So this y has already negated the rules. It must be a constant with a variable. And there is y here with a variable x. So you're having y here. Okay, this y has really affected that. So this is not linear. This is correct. This is your p of x y. This is also okay, but with this y here, that is where the problem is. Okay, if the y is not there, we could have divided through by what? By x squared. So this first one is what? It's not a linear. This is not a linear differential equation. Check the second one also. The second one, check this number 2 also. Look at it. X, y, this is what the y dx, and this is a y squared. Do you see y squared in the standard form? Do you see it there? No, 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 no. So this y squared has created a problem here. So this is not linear. This is not a linear differential equation. This one, check very well. You can see x is here. Yep, that's that. Okay, your a1 in this case is 1. Your a1 here is 1. Then you have your a naught, which you call the p of x. This is your p of x. Okay, but actually if you want to express this one in this form, then you have to divide a through by what? By x. Then you can have your dy dx equal to cos x over x y, and then equal to 1. So this is linear. This one is a linear differential equation. For this one, let's check it. Um, this is also linear. This is linear too. This is linear, whereby your what do you call it? Your p of x, because let's take it 1 over y, y prime, 1 over x, 1 over x equal to sine x. Okay, so we can make it this way, y prime, okay, plus p of x is what? Is 0. P of x here is 0 equal to what? Sine x. Then you can divide, you can multiply through by x so that this attachment here can go. So you have y prime equal to what? Plus times x, that is still the same thing here, and then equal to what? X what? X sine what? X sine x. So that one is linear. It's linear differential equation. The last one also is also linear. Let's work on this. Let's work on this. Number 5 will be equal to, for number 5, we have y prime plus 5y equal to 10x, and it's having y attachments. So y is here, y is here. We can bring them together. That will be equal to what? 5 minus 10x y equal to what? Equal to 0. So whereby your p of x in this case is what? Is 5 minus 10 what? 10x. And your f of x is 0. So that number 5 also is linear differential equation. It's linear differential equation. Okay. So yeah, how to solve a linear differential equation of this form? How? Okay. One, rewrites the given equation. Rewrites the equation. Write the equation in the form y prime plus what? P of x y equal to what? F of x y. So we write that in this form. And how do you do that? Okay, if you have in this form, how do you write in this form? Very simple. Just divide through the equation by the coefficient of your dy dx, by the attachment to your y prime. Use it to divide both sides. Okay, so by the time you do that, then you can have your y prime. So whatever fraction you have here will be your p of x. Okay, be your p of x, and then also whatever fraction also you have here will be your f of x. And you can see that we now be having this equation. We can also write in this form: the y dx plus p of x y equal to f of x. You can see the function you have here and the one you have here, they are the same thing. So this is linear. It's linear in what? It's linear in y. This is linear in y. If I have, let's say I have the v dx plus p of x v equal to f of x. This one is linear in what? In v. It's linear in v. Okay, so that's just that. So after you have written in this form, then the next case is to get the integral factor. Get the integral factor, which we call the integrating factor. It has this formula: mu equal to e integral p of x dx. So get your integral factor. So what we mean by this p of x? Just go there and pick the attachment to that y. That will be your p of x there, and it must be a function of x. Okay, it must be a function of x, and that's why we call it p of x. Okay, get your integral factor, and after you've gotten your integral factor, the next thing to do is to get the general solution. Write the general solution. Write the general solution. Okay, and is write the general solution, which is of the form y, which is of the form y equal to 1 over your integral factor. Open your brackets. Integration. Your integral factor. Okay, your integral factor. Okay, times f of x. Okay, dx. Then plus c. So that will be your general solution. Okay, for that linear differential equation. Okay, let me recap again. If you have of this form, write in this form. That means you have to what? You have to divide through that attachment of your y prime. So then after that, you have written in this form. Try to get your p of x. Once you get your p of x, you know your p of x. then you can write your integral factor. You can get your integral factor, which is mu equal to this. This is the equation for the integrating factor. Okay, and before that also, this is linear in y. This is I've explained that. Then the last step is to write the general solution of the linear differential equation, which is of the form this: 1 over integrating factor, open your brackets, integration, your integral factor, times your f of x, then dx, then plus c. This c is not with is separate on its own, and that's that on that. Let's see questions. Yeah, we have these two questions. Solve the following differential equation. The first one we can do in this question is to look at it very well and try to correspond this to this equation. Does it conform to this? Let's see if it conforms to that. Your y prime is your dy dx. Your attachment to your y is your p of x. And equals what? F of x. So this is linear equation. If it conforms to this, that is automatic linear differential equation, where our p of x is equal to what? Our p of x is what? 1 over x squared. Okay? So then the next thing to do is to write the integral factor, which is e 1 over what? X squared dx. Can we do the integral of this 1 over x squared dx, which will be equal to integral of x minus 2 dx, and that will give me that will give us minus 2 plus 1 over what? Minus 2 plus 1. If you do the integration, which will be equal to x minus 1 over minus 1. So minus will be here, which will be equal to minus 1 over x power 1. The minus here, okay? Don't forget this minus here is 1 over x to the power 1, which is equal to what? Minus 1 over what? X. So this one will be equal to e what? Minus 1 over x. So that's on that case. So then the general solution will be equal to 1 over the integral factor, which is e minus 1 over x. Open your brackets. Open your brackets, which will be equal to integral of integral factor minus 1 over x times f of x. Our f of x in this case, I didn't even state it here. If you once you correlate this the question to the standard formula, you can see your f of x is what? 0. So times 0 dx, then plus c. Okay, so automatically with times 0, the integral goes. So we have y equal to 1 over e minus 1 over x, okay, times what? Times c. So that's your answer. It says you want to do the algebra stuff there. So that's your answer. Okay, the algebra. You want to do the algebra further. This will just be equal to. Don't forget that. Just note that this e minus where we are here minus 1 over x. This power, we can write it as what? 1 over x is what? 1 over x is, that will be e x minus 1, as we have it here. You can write it this way if you like. Okay? You can write it this way if you want. And that will be equal to 1 over, this one here, 1 over 1 divided by, okay, 1 divided by, the minus here is 1 over e x minus 1, and that will be equal to 1 times e x minus 1, okay, over 1. So the answer will just be equal to CEX minus 1. Okay, let me recap that. What we are trying to do here is just, even from here, we've established that this fraction is what? Is minus x to power minus 1. Okay, so instead of having of this form, we just have minus x. 1 over x is x minus 1. Okay, so just come back here. 1 divided by 1 divided by 1 over x minus 1. Yeah, 1 divided by this minus here is 1 over. Then you have x to power e to power this one. That's that. Okay, and then you can change this on to multiplication. Then you have this will go up. Then you have this over 1, and this will give you this answer. But that's not a problem. If you are just, you can stop here. You can stop there. Question 2. Question 2. Question 2. We have the y dx minus 3y equal to 0. So in this case now, we can also correspond it to the standard form, whereby the p of x is minus 3, just a constant there. The p of x is minus 3, it's linear in y. Okay, it's minus 3, and my f of x is 0 too, in this case. So, integral factor will be equal to e minus 3 dx. My p of x is minus 3. So this will be equal to e minus 3x. Because minus 3 is just a constant. You're only integrating dx, which is what? Which is x. So in that case now, the general solution will be equal to 1 over e minus 3x into brackets. Integral of what? E minus 3x times f of x, which is 0, then plus dx. Okay, then plus c. Okay, so everything here becomes 0. So we just have 1 over e minus 3x. Okay, times c. Times c. Okay, times c. So, times c. And if you want to solve this one also, this will be equal to 1 divided by the minus here. That will be 1 over e3x. Okay, we're just looking at this one, and that will be equal to e3x times c. Okay, so that'll be your answer. And you can leave it this way also. You can leave it this way as c over e minus 3x. It's also correct. The choice is yours. Okay, so if you want to remove this one, that's just equal to minus. This minus will just be 1 over. Okay, but in a nutshell, when you have negative here as a power, and you have 1 over, this 1 over is minus, so is minus. So you are having minus minus. So automatically it will cancel out. Okay, so there may not be need for you to be doing all this. So to just give you the positive of that, to give you e to power 3x. Okay, so this minus here is 1 over e to power 3x. Okay, and this one here is 1 over 1 divided by. Okay, so that's that on that question.